Hello. In this module, we'll be talking about good characteristics of requirement statements. I mean the characteristics that we would like requirement statements to possess, to have. Now, if you would remember from previous videos that we kind of endorse using a hybrid approach where you have requirement statements and also graphical representations of the requirements and tables and so on. So we're in this case, when we say requirement statements, we're talking about statements written in structured natural language. And all these characteristics are the characteristics of those type of statements that specify the constraints, the requirements, and so on and so forth. So there are in fact 7 good characteristics of requirement statements, like completeness, correctness, or let's say a requirement statement itself, just one statement should be complete, should be correct, should be feasible, should be unambiguous, should be necessary, verifiable, and should be prioritized. I remember in previous years one of the students come up with a kind of abbreviation, and somehow we've been using it for quite a long time now. We just like said COCOFUN, complete, correct, feasible, unambiguous, necessary, COCOFUN VP. COCOFUN VP we said. Anyway, whatever. So let's see what these are. First, let's start with the completeness and correctness. So completeness, what we mean by completeness, we say a statement must contain all the information necessary for the reader to understand it. Okay? So for solution requirements, this means we provide the information, or let's say all the information the designer, the developer requires to understand, to also implement later on that particular feature. Okay, completeness is not very easy to essentially, let's say, test, and also not very easy to satisfy. But yet it is. So we have to, yet it is a very important one, and we need to strive for completeness. The second one, correctness. We have to basically accurately describe the functionality to be built and the capability that will be met, that will meet some stakeholder needs. So we may have to go to the source code of the requirement to check whether it is correct. And I should also note that the conflicting requirements are not correct. So correctness and completeness, I must say, it's not very easy to let's say determine on the spot. Usually you would see whether they're complete or correct later on in the development life cycle, but yet you have to strive for completeness and correctness. Okay, feasibility, necessity. Feasibility, let's start with that. There must be a possible way to implement each requirement statement. So that is kind of feasibility, within obviously known capabilities and limitations of the system and its operating environment, as well as within the project constraints of time, budget, and let's say staff and scope and so on. So there should be a way. There should be some sort. The current technology should provide us the necessary capability to be able to implement that thing. Not just the technology, but also the constraints regarding the time, budget, and so on. So feasibility. You might have a very nice requirement, but if it is not feasible within the constraints that we are struggling with, then of course it's not feasible. Necessary. A statement should describe a capability that provides stakeholders with the anticipated business value, differentiates the product in the marketplace, or it is required for conformance to an external standard, policy, document standard, or any kind of a directive. So every requirement should originate from a source that has the authority to provide requirements, which means that, don't invent a requirement from your gut. Okay, so don't try to come up with something that is not explicitly specified by the customer, by the user. So every kind of a requirement statement should have an origin that it should link to. Okay, so do not inject. And what we also call gold plating, avoid gold plating, meaning like making it more like, I mean, it's a very usual trap that designers and sometimes business analysts also fall into. They invent new requirements thinking that the users will like it a lot. Sometimes it works and sometimes it do not. Try to invent during elicitation, during analysis, not during specification. Okay, when you're really interacting with the users to make sure that what you invented is really needed and is really kind of wanted by the user. During specification, you're not too much interacting with the student, with the user, and if you kind of really invent at that time, go back to your analysis, go back to the users and ensure that. Feasibility, necessary, and necessity. Ambiguity and verifiability. Ambiguous, unambiguous, let's say, or let's say to put it in the other way around, every statement should be ambiguous, which means that any kind of a reader should understand or should derive the same understanding from that particular statement, from that particular requirement. And obviously reviews and inspections help to cope with ambiguity. Okay, so I mean, that's why we also do verification and validation to make sure that we understand the same thing. Verifiable, so there should be a kind of way that is attainable, by the way, that we can make sure that this is verifiable. I mean, it should be verifiable in order to determine if the product properly implements the requirements. Prioritized. I'll spend a little bit more time with the prioritization. Basically, I mean, the question that we're asking ourselves here is that which requirements are most important to achieving the desired value. So we have discussed about prioritization. That was one of the best practice, one of the good practices of requirements analysis, starting with the analysis and also continued with the specification, which means that we will have so many kind of so many numbers of requirements. And if you leave it to the user, they will all say that, like, yeah, I mean, all requirements are very much important for me, but that shouldn't be the case. So we need to really prioritize and put most of our energy and effort on those that are really highly ranked, highly important for that we are sure that it brings the highest business value. So that's why we need to prioritize requirements and requirement statements particularly. And this is particularly important for agile projects. So that, I mean, we pick the most important ones, we work on, and then we deliver that functionality and we enhance later on. What else? So there are some techniques that we can apply for prioritization, and it's a good idea to use some sort of an analytic technique. I mean, it's instead of just like doing something ad hoc. One of the ways is to look at, to have some sort of axis, two axes, and like here, like importance and urgency, and put the requirements into those kind of 4 quadrants here. So you can say, I mean, you can see whether the requirement is of high importance or low importance, or whether it's urgent or not urgent. Okay. This is one of the typical ways. Let's define that. So high priority and high urgency. So urgent and highly prioritized. Obviously, you have to like immediately start tackling these type of requirements and implement in these requirements in the early or in the first releases as early as possible. Okay, that's high priority and urgency. Medium priority but high importance. Let's put it that way. So you may have high priority, high importance requirements, but not so urgent requirements. And we may say these requirements are high or of medium priority, and we may simply wait, put them aside, and assign them to future releases. Okay. that's an obvious one. The one that is low, that doesn't have any high, let's say, is not very important and is not very urgent. Obviously, what you need to do is you need to avoid them. I mean, I mean, you should just avoid them as much as possible. Those type of you shouldn't waste time on these type of requirements. How about the other type of requirements? I mean, the fourth quadrant, those that have low priority, but somehow they are urgent. What would your opinion be here? So essentially, you have to avoid any kind of requirement that can be considered like here. Okay, yes, so you should avoid urgent but not so important requirements. You shouldn't have those type of requirements in the first place. These appear to be urgent to some stakeholders, but probably for some political reasons, but they really aren't important to achieving any business objectives. Okay, don't waste your time working on these. They don't add sufficient value to the product. I mean, if they aren't important, either set them to a low priority or just delete them and scrub them entirely. Okay. Just one note. In fact, we can have. You can, depending on the type of system, depending also on the domain, you might have different type of access. You can have different type of dimensions of priority here. So we use importance and urgency, but you might as well use, for instance, ease of implementation and importance, or urgency and ease of implementation, or you might have another dimension of like possible market value. Now, these are also other type of dimensions that you might need to consider while prioritizing, depending on the type of software, the type of solution that you are implementing. Another one I would like to mention about this, because this has been like a kind of dominant approach for prioritization. I attribute that thing because of the name. It's called the Moscow technique, and in practice it is very, very likely that you will hear about it. I wouldn't, let's say, I mean, I would definitely prefer to use analytical techniques like this, like importance, like the prioritization with respect to some dimensions, definitely a better idea. But in many cases, you will see people using, or at least referring to, the Moscow technique, must, should, could, want, or would have next time type of categorization. It's yeah, I mean, what this means that there are like mass requirements which must be satisfied for the solution to be considered a success. Those that we call should type of requirements, important and should be included in the solution if possible, but it's not mandatory. Okay, and we have these could type of statements which are desirable, but I mean, they can be deferred or just eliminated, and worse come worse. So implement those type of requirements only if there is time and resources available. Okay, so we also call them kind of nice to have type of requirements. And want or would have next time, these type of requirements indicate requirements that will not be implemented at this time but could be included in a future release. So this is again, it's I mean, as I just said, like it's a better idea to apply some sort of an analytical technique rather than just having this plain categorization. These were the, let's say, the good characteristics of requirement statements. Again, COCO1, completeness, correctness, what was it? Feasibility, unambiguity, necessity, and verifiability, and prioritization, and prioritize. I mean, okay, good. So yeah, see you in the next video.